Hello, it's Alfred Turner. I'm doing my Module 2, uh, Unit 3, Place Your Bets, Miss Benz's class. Number 1. In December 2008, 500 men and 500 women were surveyed about the opinion with the federal government bailout money should be used to help homeowners in default. The number was given each response shown below. If a person who participated in the survey is selected at random, which probability that he or she answered no, give your answers as a reduced fraction decimal to a thousand place and percent to the tenth. Based on the data of the survey, if you stopped a random woman on the street in December 2008 and asked her opinion, what is the probability that she would have said the bailout money should be used to help homeowners in default, give your answer in the reduced fraction decimal to 10,000 place percent to 10,000 place. Which probability that the person selected is a man who answered either yes or no, who would either answer yes or not sure, give the answer freshman decimals 10,000 place and percentage 10 place. Which type of probability is being used to answer these questions? Explain how you know and describe how the probability can be used or can be used. Okay, I created my chart right over here, just like they had. And on part A, the answer yes or no. It'll be half, 50%. Oh, half, 0.5, which would be 50%. If it was a woman, was that stop the woman and asked her, it'd be no. Uh, 57 over 100 because it can be reduced. 0.57 and 57%. Man, yes or no. It'd be 12 over 25. It can be reduced. 0.48. It equals 48%. Type of probability I'm using impartial probability because all the probabilities are based on actual data. Also, I'm not able to assume the outcome or also I'm not able to assume the outcome are equal likely. Number 2, that's kind of short. If two dice are rolled one time, to find a probability in getting the listed results. Write your answers, reduce fraction, decimal, thousand place, and percentage. Use correct notation to record probability sentence. Example: P of sum, event over outcome. Sum is the even, product is prime, sum is multiple of 3, and product 12. I don't think you see what I did right here. If it's even, it's 1/2, 0.5, and 50%. Product prime, 5 over 12, 0.417, and 41.7%. Sum is a multiple of 3. It's 1/8, 0.125, and 12.5%. Product of 12, 1 over 9, 0.111, and 11.1%. Number 2, moving right along. This is pretty much a long answer. So I'm going to kind of sum it up just a little bit. I'm going to cover all of it. I'm going to cover every single thing in it as far as I'm going to sum up the introduction on it. You're looking at a lottery ticket, and it shows right here in the middle, it shows in Illinois, it shows the odds of winning. The image below is the back of a $5 scratch off ticket from Illinois. That's what I just said. Um, let's see what we're trying to look. Let's see what we're looking for. Some of that above describes odds. Odds are they really odds? Describe exactly what the number represent using terminology from the lesson. Create a table using the odds on the back of a ticket. Calculate probabilities for each numerical outcome from perspective of a player, not the lottery commission. Remember, you must pay $5 for the ticket round to 3 digits after any beginning 0. Use the table to find the expected value of round 1 ticket. Run the answer to the answer places to find the mean and expected value for a lottery ticket. How much profit would it expect to make it if they sold 5 million of these tickets. Okie dokie. As you can see, I created my table. About $5. That's the probability. The normal outcomes. Um, I rounded it up to 3.075. Odds represent, it means that 1 in every 12 represents the probability of winning $5, which is be the prize. Buying one ticket. Um, uh, it $3.08. That's why I rounded up. Hold on, let me move this out the way. It's used to determine the result that it would be expected. Define meaning of expected value. What I'm doing, I'm covering my A through B. I think I went kind of fast. Like I said, A, what odds represent is the meaning that it means that 1 in every 12 represents the probability of winning a $5 prize. B, I created my table. C, buying one ticket, sum of all products equals $3.08. Once you broke everything down, the final meaning of expected value is used to determine the result that would be expected over a long term and some sort of gamble. If you were to sell 5 million of them, you would take the $3.08 and multiply by 5 million, and then it gives you 15 million for 400,000. That was a little rough, but I think I got it all in order. Moving right along to number 4. We was asked to hold on, let me go back 1 second. Find the odds in favor and the odds against. Invent with probability P B 9/13. Draw a diagram showing the odds in favor of B and write the reduced fraction decimal to 10,000 in percent. Draw a diagram showing the odds and do the same thing for us, the fractional decimal and percent. Okie dokie. Odds in favor, and it was 9/13. What I did is the number of favorable outcomes divided by number of unfavorable outcomes, which was 9/13. And it broke down to, as a decimal, it was 0.692, and as a percent is 69.2. And against its number of unfavorable outcomes versus divided by number of favorable outcomes, it was 13/9, and it broke down to a decimal 1.44, and they gave you 144%. Yeah, and that was, like I said, that was pretty short. Number 5, it told us to grab some numbers from somewhere, but I used my own numbers. Actually, my wife gave me the numbers. And they wanted me to create an Excel spreadsheet by following the one provided and the unit model. Want to label all parts. This part A right here. You see, I did it over. And find the probability that the individual on active duty was a woman, given that she was in either Air Force, Marines, or Coast Guard, right to reduce fraction, decimal, and percent. Okay, what I did, I took that Army, multiplied it by the percentage. Hold on. No, I took them. It asked for, I mean, step by step, it asked for Air Force, Marine, and Coast Guard. Air Force, I took that and multiplied by the percentage. I took all the numbers and multiplied them by the percentage, and then I add them all together. And then I divided that over the other total numbers that I didn't use, was Air Force, Marines, and Coast Guard, the whole total number. And it gave me a answer of when you see that big old fraction is 80,953 over 700,097 and 717, and the decimal was 0.101, and percent was 10.10%. Sorry about that. And number six, after taking a multiple choice quiz where there are four choices on each question only, one is correct, a classmate who scored 8 out of 10, right, he didn't study, didn't read the question, and randomly guessed of all 10. Would you believe him? Right there, bio distributing formula and plug in all values and show all work to get points for a diagram and show all steps. Write a probability that someone guesses of all questions of 8 out of 10 correct around six. Explain why you would or wouldn't believe the classmate. I came up with the formula of 1, comma, 5, comma, 2 divided by 5 true when using Excel. Um, as you can see, I didn't show my work. I do apologize for that. I guess I didn't understand when I was taking it, and I didn't even go back and make the changes. But I did. I did figure the other two parts out. Probability of getting 8 out of 10 is 0.33696. Based on the probability, I wouldn't believe him because the probability is extremely small. Like I said, I do apologize for number six, the number A part, and I do get it now. Um, Thank you for your time, and everyone, please have a blessed day.